It seems like it's time to start. And welcome back to the Top Voices channel and our community talk series. Our guest today, Ivan Timonov, developing operations and machine learning operations engineer and Tabi. And the topic for today, designing reliable SQL automation from ad hoc jobs to a predictable system. So I'm so happy to see you again here, Ivan, and I'm really looking forward for the webinar. And I think it's time to start. The stage is yours.
Thank you, Sophia. Happy to see you. Hello, everyone. My name is Ivan Timonov. I work in TEBI, focusing on data and platform engineering. Today, I want to talk about a very specific pain of many startup companies. Why a handful of scheduled SQL queries and a couple of scripts feel fine at the beginning and turn into a fragile system as soon as the company and data grow. We will look at how most teams start with just one more script, what failure patterns appear, what an SQL automation system should look like, and how to move toward it without building a gigantic orchestrator from scratch. The typical trajectory looks like this. Someone writes a useful query in a data warehouse, they schedule it in a couple of clicks or wrap it in a small cron job, and a few months later, you have a collection of scripts, crons, and UI configurations that nobody fully understands. Running and maintaining few SQL queries is not hard, but running hundreds of them every day for different teams and doing it in reliable way is a different kind of problem. As long as you have a handful of jobs, it feels good enough. Things start to break when more teams depend on these jobs. Maybe some dashboards rely on them, and you start seeing incidents, late night alerts, and unexpected warehouse bills. At that point, you no longer have just few scripts. You have a production system that is a production system, but it wasn't designed as one. The goal of this session is to show how to think about SQL automation as a system layer with contracts, validation, observability, instead of a bag of ad hoc jobs. To structure this, I'll use a very simple maturity model. It's not a formal standard, it's more of a lens. Levels are often mixed in real life, but it helps to see where you roughly are. So level 1 is UI-driven jobs, level 2 script-driven jobs, and level 3 system-driven automation, which is the target state. Let's go through them quickly. Level 1 is UI-driven. Here, almost everything is done in a warehouse console. Queries live in pop-up windows, schedules are configured via drop-downs and checkboxes, and names, labels, and environments are set case by case. The problem is the problems of this approach are obvious, that there are no central list of jobs. You don't know who owns what, and any change is done directly in the UI and often in production. The net result is that the source of truth is whatever is currently in the UI. There is no clear history, no easy way to reproduce a job elsewhere, and no real cost control. Level 2 is script-driven. At some point, the team realizes that the UI doesn't scale and we need automation. So they add cron, bash wrappers, small Python scripts, and some CLI tooling. Part of configuration lives in the code, parts in the environment variables, and parts is still stuck in the UI. Debugging is still very difficult in this case. Small undocumented changes in scripts or environments variables might unexpectedly change behavior in production. Migrating a job to a new project, region, or environment is manual and fragile exercise. You copy some scripts, adjust some flags, and hope you didn't miss anything. It's better than pure AI, of course, but it's still a chaos, just with more code. Level 3 is system-driven automation. Here, a job is no longer just a query in the UI or a custom script. A job is an object in your system with an explicit description and behavior that your platform understands. There is a clear description format, a spec separated from execution code. There are minimal contracts and policies around the jobs. There is basic observability, so you know what ran, when, and how it behaved. Reaching this level doesn't necessarily mean that you must build your own orchestrator from scratch. It's more about principles. Jobs as code, specs as the source of truth, validation, dry run, and observability. The rest of talk is essentially what does this level 3 look like and how to get closer to it. Let's define what good looks like in terms of principles. I'll go through 6 principles that show up again and again in reliable SQL automation systems. So it's single source of truth for jobs, explicit contracts, standards, validation before execution, observability by default, idempotency, and portability. We'll look at each briefly. So first principle is one source of truth. Every job needs a single explicit description, a spec that states name, purpose, schedule, inputs, outputs, owner, environment, cost limits, things like that. Without that, you can't answer basic questions. What jobs do we actually have? Who owns this one? What does it depend on, and what depends on it? As long as your jobs are defined by a mix of scripts and UI state, you're stuck at earlier maturity levels. Second principle, contracts. A job is not just some SQL that runs at night. It has a contract between platform, consumers, and scheduler. The contract answers questions like, what does this job read and write? Over what time range? And if it fails for a day, what happens? And if it runs twice, also, what happens? Once you make this explicit, you stop relying on tribal knowledge, and you can reason about your system in clear terms. Third principle, standards. If every job is unique snowflake, custom name, custom schedule, custom environment, the system becomes impossible to reason about when it scales. You need a minimal set of standards, like naming conventions for jobs and tables, a limited set of allowed schedule patterns, required metadata like owner, domain, and environment. The fewer special cases you have, the cheaper your platform is to operate. Fourth principle, validation before execution. Any change to a job, whether it is SQL, schedule, or destination, should go through basic validation before it can run in production. That validation checks that required fields are present, environments and targets are allowed, and cost or resource limits are within reasonable bounds. The key idea is that a broken job should be rejected upfront and never have a chance to run in production. Fifth principle, observability by design. A job with no logs, no metrics, and no status is a future incident waiting to happen. At minimum, you want per job data about when it ran, whether it succeeded or failed, how long it took, and how much data or cost it incurred. The information should be easily accessible, not just to the platform team, but also to data owners and data analysts, so you can operate the back and optimize based on facts and not just guesses. Sixth principle, idempotency and portability. Here, idempotency means that if you rerun a job, it doesn't corrupt your data. It might reprocess some ranges, but it should leave the system in a consistent state. Portability means that you can deploy some job specification in dev environment, staging, or production, or in different projects or regions without manual surgery. Without this, any change in environment, whether it is migrating to a new project, region, or warehouse, become a high-risk activity with lots of manual work. Now let's put these principles into a concrete minimal architecture. You don't need a huge orchestrator to get most of the benefits. A simple set of components is enough. So a place where job definitions live, a layer for policies and validation, a scheduling layer, an execution layer, and an observability layer. I'll walk through each with what it needs to do without specific tools, but with responsibilities. So first component is jobs definition store. This is where your job specs live, and not the shell scripts, not some random bits in the UI, but the source of truth, descriptions like name, schedule, inputs, outputs, owner, limits. It should support versioning and review. A Git repo is a typical implementation and have a clear structure. It doesn't matter much whether it's YAML or JSON or dedicated catalog table. What matters here is that it starts in one place, versioned and reviewable. Second component, the policies and validation layer. This layer reads job specs and checks them against the rules of your organization, like mandatory fields, owner and domain labels, allowed datasets and environments, and cost limits. Think of it as a customs checkpoints for jobs. Nothing gets into the execution system without passing these checks. This can be as simple as validator script in CI or as complex as a full policy engine. That the key point is that it's systematic and not manual. Third component is the scheduling layer. This layer answers when and how often. It takes validated definitions and manages their schedules, making sure you don't overload your warehouse and that jobs run in sensible windows. Keeping scheduling separate job from job definitions helps so you can adjust schedules without editing core contracts. And you can reason about your time-based load in one place. The implementation could be managed scheduler, an orchestrator, or lightweight servers, as long as it understands the job specs and works with them consistently. Fourth component is the execution layer. This is the part that actually talks to your data warehouse and runs queries. Its job is to translate a job spec into the appropriate API calls and to do it in a way that ensures and respects the specification, not some local overrides. It should also fit results into the observability layer, like success or failure state, runtime, and bytes which query processed. Ideally, you can trace the full path from this spec changed to this execution happens, which makes debugging and reasoning about behavior much easier. Fifth component, the observability layer. This layer collects data about executions like logs and metrics and exposes them in a usable way. You get run histories, error rates, runtimes, and cost metrics. This is valuable not just for the platform team. Analysts and product owners should be able to see when the tables were updated, and leadership should see how load and cost evolve. With it, you can manage and optimize and improve your platform. So let's run a quick self-diagnostic. Ask yourself, where does the source of truth for jobs actually live right now? In the AI, in the scripts, or even someone's head? Do you have a single list of jobs with clear ownership and purpose? Can you quickly check whether a specific job ran last night and what happened? Who is watching cost and resource usage and how? How often do reports or downstream process break because of job failed or was changed in uncontrolled way? Honest answers to these questions usually show how far are you from level 3 and which area hurts the most. The good news is that you don't need a massive multi-quarter project to improve things. In 1 or 2 sprints, you can create a simple job registry with basic fields like name, owner, schedule, and purpose. Enforce that every new job must have an owner and a domain. Turn on basic run logging so you know when jobs ran, whether they succeeded, and how long they took. As a next step, you can add simple rules for required fields, basic cost limits, naming conventions. For existing jobs, you migrate them to the new model gradually when they are modified anyway, not all at once. The long-term target is to move from a random pile of UI configurations and scripts to a stable SQL automation layer that is transparent, predictable, and can scale without your team consistently fighting fires. To summarize this, SQL automation is not just a few queries and scripts. It's a system layer that deserves proper design. Reliable systems have a single source of truth for jobs, explicit contracts, basic standards, and validation before execution. Observability and idempotency are built in, not added as an afterthought. You don't need to throw away everything and build a perfect orchestrator on day one. You can evolve incrementally. Start by making jobs visible and owned, then and add some validation, then build out observability and policies. Each small step reduces chaos and makes the system more predictable. Thank you.
Thank you very much for such an interesting webinar. Uh, as I see, there are a lot of questions in the chat box, and so that's why we can move into the Q&A session. If you have any questions, please drop them into the chat box. And the first question from Teresa. Ivan, when does temporary automation become a business risk?
Great question. Thank you. I think it becomes a business risk the moment people start making decisions of it, or downstream systems depend on it. While changes still happen via UI or documented scripts. If a failure can suddenly screw metrics, break some dashboard, or spike warehouse costs, and you can't quickly tell what changed and who owns it, then it's already in a kind of risk territory.
Okay, thank you very much. The next question is from Willie, and his comment is really clear. Thank you. Thank you, Willie, for your comments. And what's the first signal data pipelines are blocking growth?
Thank you for the question. So probably I'd say that the first signal is when you no longer can implement small changes, like, for example, adding a new column or segment without coordination between teams, manual steps, and with fear of breaking something. So you also see people duplicating jobs instead of improving existing ones, because touching existing pipeline feels very unsafe.
Okay, thank you very much for your answer. We have one more question. How much infra maturity is enough for small startups? What do you think?
I'd say that for small startup, you don't need something like enterprise governance, but you need a minimum safety baseline with a single job registry, with owner, purpose, schedule, destination, and basic logging and some validation rules. If you can list all jobs and you know who owns what, and you see how much they cost, your maturity level is enough for early growth.
Thank you for the explanation of this topic. We have one more question from Liam. What breaks first when data jobs scale across teams?
Thank you for the question. So from my experience, ownership and change control breaks first. When multiple teams touch shared logic, and the same metric starts existing in slightly different versions. So and the and observability also. Without it, debugging and turns into very difficult process.
Thank you. The next question from Sebastian. Thank you, Ivan. Super helpful. Thank you, Sebastian. How do you introduce naming standards without revolt?
Thank you for the question. So I'd propose to start with like smallest mandatory sets and force it only on new or modified jobs. So you're not asking engineers for some massive rewrite of their scripts. And after that, make it automatic in CI pipeline with some validation, so you don't need to check it manually.
Mhm. Thank you. Thank you, Dev. His question is, what makes data system fragile under T?
Good question. Thank you. I think that fragility comes from implicit behavior, like UI state scripts, environment variables, and one-off conventions that aren't visible in one place. Team growth just amplifies it, because parallel changes collide, and nobody can confidently predict the impacts on an edit.
Mhm. Thank you. Uh, Great session. Thanks. Thank you, Teresa. We have one more question. Ivan, what makes a system predictable at scale?
Great question. Thank you. Um, I would say that predictability comes from having one source of truth through job specifications, with some guardrails and validation with limits, and of course with observability level. Um, if you can trace a job on each stage, the system stays understandable even when it grows.
Mm-hmm. I'm agree with you. Uh, and one more question. I think, what's the hardest part of introducing standards?
Yeah, it might be difficult sometimes, and I would say that the hardest part is legacy that already exists, and exceptions, because usually there are some like special jobs that you don't fit in clean model, and teams resist anything that feel like friction. So the technical works is very straightforward here, but the hard work is picking a minimal baseline, automating enforcement, and keeping an exception process from turning into no standards like at all in practice.
Okay. Yes, thank you very much. I think we covered all of the questions. So thank you very much for our audience that were involved in our process, and thank you, Ivan, for leading such a good webinar and really interesting for me as well. And I think feel free to contact with Ivan on LinkedIn to keep talking and ask more questions. Subscribe to the Top Voices newsletter and our LinkedIn page to stay updated for following events, and all links can be found in the description below. Thank you very much again, Ivan, for joining us today, and for everybody. We hope to see you next time. Thank you very much.
Thank you, Sophia. Thanks, everyone.